Download this code from codegive.com, link in the description below. Composite keys, a comprehensive guide with code examples. Composite keys are a powerful and fundamental concept in database design. They allow you to uniquely identify rows in a table using a combination of two or more columns. This tutorial will provide a deep dive into composite keys, covering their definition, uses, advantages, disadvantages, implementation with SQL examples, mysql, postgresql, and sqlite, and best practices. 1. What is a composite key? A composite key is a primary key composed of two or more columns in a database table. Unlike a simple primary key, which uses a single column to uniquely identify each row, a composite key relies on the combination of values across multiple columns. No two rows can have the same combination of values for all the columns that make up the composite key. Key properties **** uniqueness **** the combination of values in the key columns must be unique for each row in the table. **non-null * like any primary key, no column participating in a composite key can contain a null value. A null value violates the uniqueness constraint. **identification ** the combination of values in the key columns uniquely identifies each row. **immutability Ideally, while not strictly required by the database system, it is generally best practice for the columns in a composite key to be immutable, unchanging. If the values change, it can cause cascading updates to foreign keys in other tables that reference it and lead to data integrity problems. 2. Why use composite keys? Common use cases. Composite keys are most useful when a single column cannot uniquely identify a row. Some common scenarios where composite keys shine include many-to-many relationships. Intersection tables consider a scenario where students enroll in courses. A student can enroll in multiple courses, and a course can have multiple students. To represent this many-to-many relationship, you'd create an enrollments table. This table would typically have columns for student_ID and course_ID. Neither student_ID nor course_ID alone can uniquely identify a row. The combination of a specific student_ID and a specific course_ID represents a unique enrollment record. Thus, you would use student_ID and course_ID as a composite primary key. Historical data /versioning If you're tracking historical data or versioning changes to a record, a composite key might include the original key columns plus a version or effective_date column. This allows you to have multiple records for the same entity, identified by the original key, but with different historical versions or states. Composite natural keys Sometimes, the real-world entity you're modeling has a natural unique identifier that is already composed of multiple attributes. For example, if you're storing geographic data for a city, you might use state_code and city_name as a composite primary key, assuming the combination is unique within your data. Be careful with this, as natural keys can change. It's often better to use a surrogate key, auto-incrementing integer, and create a separate unique constraint on the natural key columns. Parent-child relationships within the same table. Hierarchical data In scenarios involving hierarchical data, a composite key might combine a parent_ID column, referencing the parent record in the same table, with a column that is unique within the scope of the parent. 3. Advantages of composite keys. Natural representation In some cases, composite keys align more closely with the natural way you think about the data, reflecting the real-world unique identifiers. Data integrity enforces uniqueness based on the combination of values, ensuring data consistency. Improved query performance. Potentially, if queries frequently use the columns in the composite key in their where clauses, the database optimizer might be able to leverage indexes more effectively. Asterisk relationship modeling. Asterisk essential for accurately representing relationships in the database schema, particularly many-to-many relationships. 4. Disadvantages of composite keys. Asterisk complexity. Asterisk composite keys can make the database schema more complex, especially when dealing with many foreign keys referencing them. Asterisk performance impact. Potentially larger keys can lead to larger indexes, which can slow down write operations and increase storage space. Query performance benefit is not always guaranteed, depends on usage patterns. Asterisk maintenance overhead. Asterisk updating or modifying composite key columns can be more complex than updating a single column primary key, particularly if there are foreign keys referencing the composite key. Asterisk readability. Asterisk queries involving composite keys can become more verbose as you need to specify multiple columns in the where clause or join conditions. Asterisk easier violation by bad data. Asterisk since the composite key relies on two or more values, bad data for either values can violate the constraint. 5. SQL examples, creating tables with composite keys. Here are examples of how to create a table with a composite primary key in different SQL databases. The example will focus on the enrollments table used in the many-to-many relationship between students and courses. Example table, enrollments. Column data type description. Student_ID int foreign key referencing the students table. Course_ID int foreign key referencing the courses table. Enrollment_date when the student enrolled. Grade varchar, 2, letter grade received. MySQL. PostgresqL. SQLite. Explanation of the code. 1. Create table enrollments, creates the table to store enrollment information. 2. Student_ID int, course_ID int, defines the columns, student_ID and course_ID will participate in the composite primary key. 3. Primary key, student_ID, course_ID, this line defines the composite primary key. It specifies that the combination of student_ID and course_ID must be unique. 4. Foreign key, student_ID, references students, student_ID, defines a foreign key constraint, ensuring that the student_ID in the enrollments table exists in the students table. 5. Foreign key, course_ID, references courses, course_ID, defines a foreign key constraint, ensuring that the course_ID in the enrollments table exists in the courses table. 6. Inserting data and demonstrating uniqueness. Now, let's insert some data to see how the composite key enforces uniqueness. The last insert statement is commented out because it would violate the composite key constraint. We are trying to insert another row with student_ID equals 1 and course_ID equals 1, but that combination already exists in the table. 7. Querying with the composite key. Here are examples of how you would query the table using the composite key. 8. Composite foreign keys. You can also use composite keys as foreign keys in other tables. Suppose you have a table called attendance that tracks attendance for each enrollment. The attendance table would need to reference the enrollments table. In this example, *student_ID and course_ID are part of the composite primary key of attendance. The foreign key, student_ID, course_ID, constraint references the composite primary key of the enrollments table. This ensures that you can only record attendance for valid enrollment records. *attendance_date is included as part of the primary key, making it unique for the same student_ID and course_ID on the same attendance_date. 9. Best practices for using composite keys. Keep it simple. Only use composite keys when a single column primary key is truly insufficient to uniquely identify a row. Overusing them can lead to unnecessary complexity. Use small data types. Smaller data types, example integers instead of long strings, for the key columns will result in smaller indexes and better performance. Immutability. Strive to make the columns that comprise the composite key immutable. If values must change, carefully consider the implications for foreign keys and data integrity. Consider surrogate keys. If you're using a composite key because of a natural key that might change, it's often better to use a surrogate key, auto-incrementing integer, as the primary key and create a separate unique constraint on the natural key columns. This provides more flexibility and avoids cascading updates if the natural key changes. Indexing. Ensure that the composite key is properly indexed. The database system typically creates an index automatically for the primary key, but if you are also using it as a foreign key, it may be beneficial to explicitly create an index on the foreign key columns. Understand the performance implications. Test the performance of your queries with and without the composite key to ensure that it's actually improving performance and not hindering it. 10. Alternatives to composite keys. Surrogate keys, auto-incrementing integers. As mentioned earlier, using a surrogate key as the primary key and creating a unique constraint on the natural key columns is often a good alternative. UUIDs, universally unique identifiers. UUIDs can be used as primary keys and guarantee uniqueness across different databases and systems. However, they are larger than integers and can impact performance. Combining existing keys with an additional column. In some cases, you might be able to add an additional column to your table, example a sequence number or version number, to create a unique primary key without resorting to a full composite key. Conclusion. Composite keys are a valuable tool for database designers, allowing you to accurately model relationships and enforce data integrity. However, they should be used judiciously, taking into account the potential drawbacks and performance implications. Carefully consider the alternatives and choose the solution that best fits your specific requirements and data model. By understanding the principles and best practices outlined in this tutorial, you can effectively leverage composite keys in your database designs.